You can meanwhile connect to the link as usual. I'll do a copy paste of this. All right, we're all ready? Cool. Let's start. So, yeah, we're going to do the usual small quiz, some questions, some material. Let's see. Okay. So, in today's lecture, we'll start with the quiz in about a minute, and then we'll do something different than last times. Yeah, hopefully that doesn't disappoint you, but we're not going to talk about the assignment yet. I received about, I think, a bit more than half of the people have submitted the assignment so far. And yeah, it takes quite a lot of time to check all of them, and a lot of you still have some questions about how to get around it. So what we eventually decided to do, so it's the following. You're going to reuse the code from this assignment in another one a bit later. So as we are now, well, next time, we're going to start learning about servers, databases. You're going to implement the same assignment, but with a proper web server and so on. So it will be kind of clear a bit later. You will use the same code plus with a bit of the backend stuff and so on. Yeah, if you have the code already done by today, so more than half of you, you'll pretty much just reuse the same code. If no, you'll have you'll still have quite some time to make it in a more professional manner. Also, you're learning more skills every week, I guess. Yeah, so that's about it. Also, I checked last time, and last time it takes about 45 minutes to discuss the assignment. So we have quite a lot of material today to go through. It's really some really interesting material. So yeah, better make sure we have enough time for that, so I don't have to speak very fast. Okay. Let's start with the quiz. You have the link in the chat. There's only 6 questions today. So I see 20 people in the... I see 20 people logged in and 29 people in the chat. Let's wait for you. Anything I can do next time to make this faster, or is it simply 9 people who don't want to join? Okay, I'll give you 10 more seconds, I guess. All right. Well, 21 people it is then. Okay, let's start. Yeah, now you have to join with the name and so on. Yeah, having a name that I can later associate it with your real name would be really helpful and useful. But yeah, but if you just give the assignments and time and so on, yeah, there's probably no need to look into your score here. All right, so 1 more player. 2 more players. Okay. And we're starting right now. Yeah? Cool, let's start. Well, yeah, I hope I put enough time for them. Well, anyways, what is the output of this code? Yep. You have an array, you have a second one. You change a variable in the first, you change a variable in the second one. All right, we've got 9 answers. 3, 2, 1. Yep, let's see. So most of you got it right. Yeah, so if you don't remember from the last slide, the last lecture, we're speaking about the spread operator and about copying by reference and copying by value. So yeah, go back to it and learn about what those two terms mean. And yeah, let's go next. Question 2. What is the correct way to read a property of this object or any other object? Cat square brackets size, cat dot size. Maybe they're both correct, maybe they're both wrong. Yep. And yes, they're both correct. So yeah, more often you're going to use the dot notation. But as I showed also last time, both variants are fine. And yeah, so the first variant, the one with the square brackets, that's more useful when you want to give a parameter with a string name. But usually the second one is preferable. But yeah, they're both correct. So next. How do you type the spread operator in JavaScript? Yeah, 2 dots, 3 dots, dot spread, 4 dots. Okay, most of you answered like really fast. Cool. And most of you got it right. Yeah, it's 3 dots, not 2. A dot spread, such a thing does not exist until you declare it yourself. So yeah, that's about it. Question 4. Which function creates an array of keys out of an object? Yes. So yeah, in case it's not clear, if you remember, there was a function which you call it on an object, which takes an object as an argument. And what it gives you back, it's an array with each of the keys in order. Let's see. Time's up. Yep, object.keys, absolutely. That's just pretty much have to learn this by heart. All right. And the last one. Yeah, this one is one of those annoying, tricky ones, but it's typical stuff you'd get in a job interview. Okay. So yeah, this also is something very specific to JavaScript. Take care of what's a string here, which one is a number. Yeah, let's see how many of you get this one right. Okay, so most of the, half of the people got it right. Yeah, in case, it's also a very good thing to come back to later when you'll get the slides. This is one of the reasons why we do not concatenate strings with plus, because you can have this kind of situation. So this is a real life situation where you might end up having a bug, and sometimes you're surprised, why does that number come up? Well, the reason is that the first two parameters of that plus operation, there were numbers. So JavaScript looks at them, it adds them up, and you have 7. But then the third parameter is a string, 3 as a piece of text, let's say. And yeah, adding them ends up in a concatenation procedure function, which usually it's not something that you expect as a developer or anything. So yeah, take care when you have those kind of things in your code. Let's see who wins. Mihaela, Makar, Hostuk, Robert, Marcella, Samuel, Anna, and Ricky. Good job. Yeah, good job, I guess. Let's move forward. So we're done with that. So what we're going to learn today, it's going to be APIs, web servers, a bit about networking, without going much to depth in, into all the nerdy stuff. So far, we're just using, we're just making small web pages. We're just running JavaScript in Chrome in the browser, which is a pretty nice environment to learn JavaScript. And, you have a very nice debugger. You see, you have this console on the side. You can inspect each of the elements. So this is pretty great. But yeah, when you go on any kind of website nowadays, you are using the information from multiple sources, from multiple servers. You're interacting with databases. So the internet is way more complex than just hosting web pages and sending them from user to user. Where do I start? Let's start with the word API. So what's an API? And it's very important to understand that you need to learn about APIs even if you're not looking into a software developer job, even if you're not looking in the tech nowadays. In the next decade, if you don't know about APIs, you're going to have a hard time, as a business owner, as an online shop manager, as honestly anything, data scientist, just manager in a company. Like everything nowadays is automated or semi-automated or will be automated at some point. And APIs are one of the things that allow you to do that. So yeah, the general definition of API is application programming interface. So that sounds quite, let's say, in general, some other some other notions that I found. A set of functions or procedure used by computer programs to access operating system services, software libraries, or other systems. So that maybe explains it a bit more. And this is the most human understandable explanation of what an API is. A tool that allows for automatic transfer of data from one program to another or more applications or programs. Okay, so it's a protocol. It's a way in which a program communicates with another one. So where are APIs used? So very first, the most typical thing where an API would be used in the environment of a web application. So for now, you're building web pages, right? So this just runs on your computer. You run it to the file. In the future, you're going to learn that, okay, you can host that web application on some server somewhere, but it's still a very static application. It doesn't do anything. It just displays the stuff that it's been told to display. Now, let's say you go on Facebook or you go on Twitter or you go on, I don't know, literally any application that has a web server behind it. What happens is that you receive a web page, and the web page has some code in it that knows that I have to interact with this web servers all over the world, and I have to display this information to my user, okay? So this is done through requests and responses, right, towards web servers all over the world. So the description of how your web page or your application or literally anything that you can write code to, so the instruction on how you should interact with that web server, that's pretty much called an API, okay? So you're going to get some examples. Maybe it gets a bit more clear. But the thing is, yeah, API is pretty much an agreement on how two devices should communicate, two pieces of software. They can be on the same computer. They can be distributed all over the world. And nowadays, all the information everywhere is going through some sort of API here and there. And a component of what typically a web server has. The web server runs a very simple application with some logic, but all your data is usually stored in a database. So if we speak about the web shop assignment that we're talking today, that we had to do for today, all the data of your products was pretty much was disappearing every time you refresh the page, right? Like, because you don't save that anywhere and no one else can see that information. Well, normally a web shop, how it would be done is that you have that static web page, something like what you did, but obviously a bit more complex. Then you'd have a small web server, probably in the cloud. It can also be a small computer in your house. It's also possible. And that server is going to have an API, so pretty much an agreement of how your web page should interact with that web server. And then every time you request for a new product, for example, that web server will look through a database. And a database it's pretty much just a way. It can be anything. It can be just any kind of way of storing files, static information, right? So any kind of information that doesn't disappear when I plug out and I plug back my computer. It's good enough for a database. So so if you now reimagine your web shop project, what you would have to do is that inside the database, you have information about products, maybe you have information about clients, and then you from the web page, every time you want to see that information, you have to send a request to the web server. So we're going to learn about each of these components one by one. As a full stack developer, you need to have a good understanding of each of these elements. So pretty much we're going to start from left to right. We got to some decent level of web page development, right? I mean, we learned some JavaScript, and again, the learning will never end. There's never like a maximum level you reach in web page development. And now we're moving to the next element, which is APIs. Today we're not going to develop our own web servers, but we're going to interact with web servers around the world. You're going to see that today. And then towards the end, we're going to learn about databases. And then that's how you are going to learn the full stack. And that's what it means to be a full stack developer, is to be able to deploy and create an application which interacts with each of these elements. So a bit further, okay, so what kind of APIs are there, right? Because the discussion was very abstract until now. Honestly, like, if there is something that has any kind of digital data, chances are there's an API for it, right? There's a Facebook API, there's a Twitter API, there's an API. So, I'm thinking how to say it. Well, anyways, APIs are the most simple thing of APIs is to get information, right? Let's look at the example of let's say you have an AccuWeather API. So this is pretty much a service. You can go on their website, which they host multiple servers where if your program sends a request to it, you can ask, what is the weather in Chisinau? And what you'll get back, you'll get a list of information about the weather in that city. You'll get it in a very structured, in a kind of a text object notation. And then your application can then read those variables that you get in and display them in the way you want, right? The Cocktail DB is, for example, it's an open API which you can send it to 2 or more drinks, and it will give you back names of drinks, and it will give you back a list of cocktails that you can do with those drinks. So you can all of a sudden make a cocktail app in the browser without even having to program all this logic and have all this data about all the cocktails, because it's just given to you for free, okay? COVID API, same. Like every time you go on a COVID statistic website, you probably did that at least once in your life to see, some plots and graphs. What normally happens is that website will send a request to a server which contains all the data, and the server will give back, okay, these are the numbers in the last week, last month or so. There's APIs, the football API. This is a very nice one for the sport lovers. Let's say if you want to make an application where you show all the scores of a specific team, or if you want to, check their website and you'll understand what it is it's specifically for. So far I only told you about APIs where you read information. So that's already quite empowering, so to say. But also there's APIs which your application can control something, okay? So for example, not only requesting information, but actually making a request or doing something. A very nice one is the PayPal API. You can write a program which it would be stupid, but you can write a program which downloads the list of all your Facebook friends. using the Facebook API, and then using the PayPal API, you can send $1 to each of their accounts, right? You can program that without you having to manually do that, because they give you these interfaces, so you can, so your program can automate those operations. So a Shopify API would be probably like that. You can do something like every time someone buys a product, you want something to happen, right? Maybe you want him to receive an automatic email, or you want him to, or you want to update something in a database, or you want to send him a coupon. So, so I think that pretty much describes what APIs are. Before I move on, do you have questions, or are you surprised, or is this like very new or very not new information to you? You can also speak with the mic.
It's fine.
Yeah, nothing surprising. I mean, you've heard about this before?
Not completely, but...
All right. Okay, so before we, so the next thing I want to do is to pretty much show you where we're actually going to connect to some of these APIs. We're going to, for the first try, actually, that's going to be a surprise, I guess. Anyways, before we go into how to make an API request from JavaScript, surprise, Stripe didn't take the list. Stripe, oh, okay, yeah. I mean, there's a lot of them. Before you learn how to make a request to a server, you have to understand something in the JavaScript language and in general in programming. So there's a term called synchronous and asynchronous. Okay, so it's quite important to understand that in programming. Usually, when you like back in the days when you started a new programming language, like C++, Pascal, or so on, you wouldn't learn much about the synchronous programming. This was always something that you would learn only like at a very high level. But in JavaScript, also considering you're making end user applications, it's very important to understand the concept of asynchronous. As it means exactly what it means, I guess, in English language. Synchronous is something that happens sequentially one after each other. So synchronous code is pretty much most of the code that you've written so far. You type in a line, and then you type in the next line, and so on. And your compiler, your interpreter or whatever, will take each of the lines and run it one after each other. Very straightforward. Okay, so that's how you normally expect your code to behave. Each line one by one, and and that's. I guess that's how software works. However, you already interacted with the synchronous part of JavaScript without probably even realizing. When did that happen? Is pretty much every time you did a button on click, or every time you made some event happen when a user would type in text or the user would click a button, that is actually asynchronous code, because that code can happen at any point in time. It can happen multiple times or never. So that's asynchronous code, right? JavaScript and in general applications which are in front of the user, end user applications, they cannot exist without a synchronous execution of code. Okay, so other situations where you need the synchronous is what you see here. These are two functions, set timeout and set interval. These are two functions from JavaScript, which allow you to do pretty much what this text tells you that it does. This function takes a function as an argument, and the set timeout, whenever you declare this in your code, after this many milliseconds, so this would be 5 seconds, this will happen once, right? So if you want to, for example, those annoying pop-ups on the website when you get on a website, and then in 10 seconds something appears, So what most likely is behind that is a set timeout, some seconds, and in the code like show annoying stuff to your user, or anything like that. Another thing, and this is asynchronous. This is pretty much asynchronous code, because it does not run sequentially. You tell it that it's going to run at some point, and even if there's other code running in parallel, this will run after those 5 seconds, unless your computer is like overloaded or so on. But like this is just high performance stuff that you have to learn a bit later. But the other thing is set interval. So again, it's pretty self-explanatory. You give, again, a function as a first argument and a number of milliseconds. And this will happen every time, in this case, every 2 seconds. So if you want a piece of code to be reoccurring, to run every 2 seconds, I guess, this is how you would do it, right? There's also a way to stop this set interval, but unless you don't stop it, as long as your user is on that website, this will continue running every 2 seconds once. And in parallel, you can have a lot of other code happening, right? A lot of other actions happening. So that is pretty much the synchronous nature of JavaScript. And now, why it's important to learn synchronous when working with web servers and APIs. Well, the internet, just like the users, is a very unpredictable place, okay? Let's say you want to send a request to a server, you just shoot it out, it goes through a lot of nodes, it goes to your local internet service provider, then it goes to some other node, maybe it goes through a lot of places, and then it reaches out eventually that web server that you're sending the request to. And then that web server is also maybe busy at that moment. Maybe it's queuing up a lot of other requests from 1,000 of other users. And then at some point, it gets to your request. It checks it. It finds out, okay, I have to give this information back. And now the information is shooted back to you, back to your computer. So this time is very indefinite. And also the chance of it not working, there's also a chance of it not working because poor internet connection, because that web server is not available. You can have slow connection, right? Sometimes it might take 20 milliseconds. Sometimes it might take a whole second, right? So when you send a request, you never know when you're getting the response back. Meanwhile, you don't want your whole web page to freeze and to wait for that response back, right? So if let's say, I'm thinking of a use case. Let's say, maybe a stupid example, but let's say you have a chat app and you're sending a request to get the latest messages. You don't want the whole web page to just freeze and wait until you get a message back. What you probably want is that there's a small piece of code that sends the request, kind of waits there, but meanwhile your whole page is responsive and you can still do stuff inside it, right? So and then later you have to also explain what should your program do if the request wasn't successful, right? What if I send a request and I expected back some information, but I didn't make it through? You don't want, again, your whole web page to crash. You want maybe to show a small error to your end user, or maybe you want to tell him, your internet is bad, or you want something to happen. All right, so now we're going to go, to actually look at what kind of code you would use to do an HTTP request, to an API request, HTTP request. I'm about to explain that as well. So we're going to first look in the old way. So both of the things are asynchronous ways of sending a request to a web server. Okay. So first of all, you see this URL here. Let's see what does this URL like. Let's see what this link is about. So we're going to go to https blockchain.info. So this is our website. Right? Oh, crap. Where was it? Yeah. So there you go. So this is our website. And this is just, like a page where you can see prices in very fancy ways and very, very fancy plots. You can see the prices of some cryptocurrencies. But also, they provide a free of use API that you can use in your own applications to just get what you care about, these numbers, right? So if you go to the full link, blockchain.info/ticker, there you go. So what do we see here? Last time we learned about objects, right? About JavaScript objects. And maybe some of you, I just got a message. What will happen at the 10th second? What log will be printed first? Or we can't really tell. Andrei Rarenko, yes, very good question. This is a question about set timeout and set interval. Yeah, well, when you program like embedded controllers or, you found your answer? Well, anyways, I'm going to explain it. You can't really tell, maybe the answer is, but most likely the first one that was declared. Again, you'll never have exact precision of 5,000 milliseconds. You might win one or lose one, or it all depends on how your program runs and how powerful your computer is. And in this case, will be only the second one. No. So if you write these 2 lines of code, let's do it. Set timeout. Let me use a bit of cheat codes here. Yeah, let's save it. And now I'm going to open that web page. Where was it? I think like that. There we are. So yeah, let's open the console. And yeah, what we see here, this will happen every 2 seconds. Again, don't forget that Google Chrome is like aggregating those messages together. And yeah, this will only happen once after 5 seconds. That's true because set timeout. But if I make this a set interval, honestly, I don't know exactly which one will happen. But the thing is, you don't use this for very, let's say, time-critical applications, right? You use this for applications where you don't care about whether it's going to be, 1, 10, 20 milliseconds later or before, right? If you need very specific timing, usually there's other ways, but in an end-user application, you don't care, right? Like you can't predict time in an operating system. In this case, will be second one. No, the first function set timeout. Yes, correct. Anyways, okay. So that's about the synchronous. Now, we're going to learn about the fetch function. So the fetch function is something that allows you to send something which is called an HTTP request. All right. So an HTTP request, it's a way in which computers talk over the internet nowadays. They talk through a lot of type of protocols and so on. There's voice over IP. There is, like video streaming protocols. A lot of stuff that, you will learn it as time goes and so on. But the most common way of how web pages are sent to you or how requests are sent on the internet are through the protocol called HTTP. This is, in fact, the protocol that also gives you the pages, right? Like every time you go on a link, you always see this HTTP or HTTPS, right? If you have the secure encrypted version of it. So in the same manner in which you send a request to get a web page, in the same manner, you can send a request to just get something which is not necessarily a web page. In this case, a JSON file. So JSON, JSON, is JavaScript Object Notation. These are pretty much those JavaScript objects that we learned last time in the assignment, but in a text way. And the cool thing now is that the JavaScript Object Notation became one of the main standards of how APIs work, of how servers communicate, of how users interact with servers. It's a way in which people store data, in which they store logs, information. So luckily for us in JavaScript, to move from a text notation of an object to an actual object, it's a one-liner. In other languages, you actually need to do something called parsing, where you actually look at each of the elements and try to transform it to some sort of logical abstract notation. But in JavaScript, if we read this information, this is an object with keys, which has another object with other keys and some numbers inside it. Okay, so something important to know is that every time you go on a website, there's a lot of requests sent from that page to other places. Zoom, please. Yes. So this is how that code looks like. This is what we get when we go on this URL. So normally Chrome expects an actual web page, but because it didn't find a web page, it just found something in this JSON text format. It tries to display it any kind of way it can, right? So one way to see what your web page, where is your web page connecting to, is to go in this console, the Control-Shift-I, and go to the section called Network. And usually you have to, because it doesn't log absolutely everything, because that would kill your computer. When you have to refresh the page, and if you refresh it, if we look at all the, you put all to see all kind of connections that your website is doing, we see two things here. Well, this is just something that gives you this icon up there, but small detail. The main thing that is important is that we see that when we did this request, we got this information. Here we see it in a nicer way in a JSON format. And let's say, let's try another website. Let's if you go, for example, on 9gag, right? So if we look at what is our network doing, there's a lot of information here, right? But you also notice some of them are red. This is because these are all events from Facebook events, stuff that tries to give you ads. So because I have ad blocker, what happens is that all these requests, which were supposed to give my personal information, every time I scroll through a mindless meme website, every time you scroll, there's a lot of requests sent to Facebook, to Twitter, to all these companies, to Google especially. And that's how eventually they know what kind of ads to give you, right? Because they know where you stopped, what you did. So every time you actually do some action on a web page, some requests are being sent to a lot of other servers, right? So sometimes if you find that a certain website might be fishy, so to say, you want to take a look at what exactly you are sending there. Like what is your web page trying to send back or receive? And now we see that, let's say, every time I scroll, I send a request to give me the next 10 posts, right? Because I'm not always downloading all the posts. So let's take a look. What we see here, this might be a bit complicated, but let's try to find a request that kind of makes sense. Preview response. No, not what I wanted to show you. Very strange. Give me a second. XHR. There you go. No, they did change their API last time I checked. But anyways, the idea is that, every time I scroll, there is a small program inside this web page that will say that every time you scroll to the bottom of it, send a request to the server to give me 10 more posts, and so on. So that's the idea, that every web page, as you go through it, it does a lot of these connections to a lot of servers around the world. Now, so coming back to this. Now, what we want to do is that we want our program to request the information at this URL. We want to take this information, transform it to an actual object that we can actually access each of the elements. And then we want to display it in some sort of nice way. So how are we going to do that? This is the structure of a HTTP request done in JavaScript. So the function called fetch takes in multiple arguments, but if you're just getting some information, you can use just one argument, which is the URL, right? So you have to say it where do you want to take that information from. And now, when you run this piece of code, you don't know when you're going to get the data back, right? Because, let's say if I take a look here, there's also a small plot here explaining how much time a certain event took, right? So this one, yeah, it took 61 milliseconds, but some requests with more information can take way more time. So yeah, we see like all the timing. I sent the request that took 30 milliseconds, right? So this is the fetch. And then while I was waiting for the server to give the information back to me, that took 84 milliseconds, right? And then the content was downloaded. So it took 68 milliseconds for this information to pretty much be downloaded bit by bit and then appear on my screen. So it doesn't happen instantaneously, right? Even if it's only 64 milliseconds, maybe it's not a lot, but I think you do a lot of this requests and you'll definitely feel that if you do them in a synchronous way, then you definitely feel the lag, right? So what do we do here? When we do fetch, we don't read the output of this function, but classically the way you would do it, you do something, these are called promises. So a promise, we're going to go a bit more into details of how to use promises and why not. But for now, what's important is that a promise is pretty much you promise your JavaScript compiler that you're going to get a response from this function. And when you get the response, you want to do something with that response, right? So you do fetch, do .then, and what you do here, you write in a function. We're not going to go in the function for now, but I think it makes sense that we try it now. Let's try to do fetch. And you can even do stuff like, I think google.com. Yeah, let's not go into that. Let's focus on this, I guess. Well, anyways, let's try to put in that link here. We're going to do fetch and zoom in a little bit. And if I save, I open this web page. Take a look here. We do a console. We don't see anything, right? Because we don't print anything. I just did a fetch. Like it probably did a request, but I didn't see that. Let's take a look at the network. This is my web page from my computer, right? It's inside of index.html. I refresh now again. And I see that every time I refresh the page, I do a request. And you have all the information about it. Yeah, normally you have more screen space. And you see that I sent this kind of request. Request method is something that we're also going to learn a bit later, but every time you don't specify it, it's a get. This is like something that means that you want to get the information from that endpoint. Later, we're going to learn a bit different ways. There's a status code, something you should already learn soon. I have a slide about that. A status code is without having to download all the information, you want to know if the request was successful or not, right? And we're about to show that. And then a lot of information about the whole request, because even if I only sent a URL, with it, there's a lot of other data that went. It's a lot of it. And you're never going to understand all of it, but yeah, just keep that in mind. And then in the preview, we see what we received back, and we see this nice, this nice JSON. And we see it's structured nicely, and we're about to understand what's actually inside that JSON. But in the console, I have nothing about it. So what we want to do now is we want to tell the compiler what to do when that code is received, and to also maybe give you a better understanding of asynchronous. I'll also do a console log here. Request sent. Right after the fetch, I'm going to say request sent, but when the request is received, so this one takes in a function. Let me use the bracket so it's not confusing. So the .then here, you put in a function. You give any argument name you want. It can be R, S, D, whatever. If you want to be more explicit, you write response. This argument is going to pretty much be this output, but yeah, actually let's print it out so it gets more clear. I'm going to first do a console log response received. So I want this message to appear, and just before I even show what's in that object, when I refresh, you see that I first type request sent because this is exactly after the fetch. and then my code execution has finished. But then this asynchronous part says that, yeah, I said that, okay, when I receive an answer from you, then run this piece of code. So obviously this is going to run secondly, even if structurally this looks like this piece of code is before that. This actually gets executed only when a response is received. Okay, now let's see what is this response object. And let's refresh. Now, the response object might have a lot of details that you do not care about, right? Later you will start caring about them. But we see the following thing. We have the URL. We see that we have a status of 200. So this is a successful status. Those codes you can always pretty much Google. There's a lot of them, and you never need to learn all of them, but you can always find them on Wikipedia. There's better graphs with this, but anyways, we see that 200 generally means okay. So this is a successful response, I guess, as it was expected. And then, yeah, we see some other parameters, which later you're going to learn, or maybe not need, or maybe you'll need them. But these are parameters which tell you if the response was successful. But we see that we do not have that data yet. We still don't have the actual data that we care about. By the way, if you don't mind, let's do a break for 4 minutes, 4 or 5 minutes, right? And meanwhile, prepare any questions you have. See you in a while. So I'm back. Anyone still in the break? Welcome. Thanks. Okay. So back to this API request, this HTTP request. So what I've seen so far is that we, in JavaScript, by using the fetch function, we can request the data at a specific URL. And then, do you guys have Dogecoins? No, do not invest in that kind of crap. Cryptocurrency, maybe it's okay, but don't buy every shitcoin out there. Anyways, so using the fetch function, you can get the information at a specific URL, at a specific link, and then you can specify a function, a method that has to run when that request was received. And we see that the response that comes to us comes in shape of a JavaScript object, which is, which has all the information about the request, everything except the data itself. Okay, so you're wondering, like, why in JavaScript didn't they just say, okay, why not just give also the information and kind of display it? Well, the reason is that at every link, at every URL, you can have data in a lot of types of formats, right? So when you just go to a web page, that's an HTML format, right? You're given back a file. You can also get image, video. You can get like binary data for, let's say, if you can have a binary data stream if you have, like, let's say, an online multiplayer game. So the data can be in really a lot of type of formats. And the next thing that you have to do is you have to tell JavaScript, all right, I expect the data is in this format. Please decode it for me. Please show it in a specific way that I can understand. So we already know that the data at this endpoint, at this URL, comes in JSON format, right? So we already know that. So what we want to do is that we want to transform this information into actual text or actual data. So the way this is done is that if we know that it's in JSON format, we can do the following. Response.json. And this is also an asynchronous function, okay? So this also is, when you write this code, this procedure starts to be, the procedure is initiated, right? So that piece of data is starting to transform into actual JavaScript object. However, the reason why it's asynchronous is because, okay, maybe this piece of text is not that big, but a lot of times you can have like megabytes of data that you download, and then you have to process them. So again, you don't want this piece of code to be synchronous, because otherwise, every time your web page is doing a request to some other web server, if it's like a 1 megabyte thing, you're going to have to freeze your whole website, wait until that megabyte is downloaded, and then you continue doing stuff. So obviously you don't want that for the user. And it simply doesn't make sense to have such a website. So that's why, this is also asynchronous. Again, we use a .then. This is also something called a promise. Yeah. So we want that when this procedure is done, we want something to happen with the result. So we're going to give it a different name, absolutely in the same manner as on top. And you already see the code starts looking pretty deep, I guess. We already have like this callback inside a callback, and it's starting to be a bit not clear what's happening. So you're about to see how people solve this in the latest JavaScript standard. But for now, let's do it the classical way. So we now want to display that in a human readable format, more or less. So we're going to do console log res. So pretty much we want to see the output of this operation. Save, boom, there we go. We have our JavaScript object right here. And now, okay, let's get a bit of an idea of what's inside this data object, because now we want to, let's say, maybe make a small application with it. Yeah, so this is a very simple, pretty much, it gives you the latest price of Bitcoin in a list of currencies, right? So if we look at dollar, we see that one of the parameters of the main object is USD. So let's see, first of all, look at the USD part, right? So if you remember from last time, accessing a parameter is done through the dot. You can do it this way. If it's a more complex word, you can also do it this way. Yep. So let's see what is just the rest.usd. So if we refresh, again, we see the main object first because we're printing that. And then we are seeing only the data about the US dollar, right? And we have some other parameters like the value averaged in the last 15 minutes. This is, I think, the latest transaction price. The general size price to buy, to sell. I don't know if you're into finance and stuff, you probably understand. And then there's also a symbol just for you to maybe use in your code to make it look nice. So we can, now write a sentence like the price of Bitcoin, and let's do a bit of string concatenation here, is dollar. And we're going to say res.usd.last. Yeah, so we want this parameter. And we also want to show it, because this is dollars, we also, just after it, we want to use the symbol. So this API gives us the symbol right away. And we're going to say res.usd.symbol. Save. Refresh. The price of Bitcoin is 62K. So there you go. You made an application that tells you the price of Bitcoin. Now, coming back to the presentation, I'm about to come back to this newer way. Coming back to the presentation, you'll also be able to try this code here. So what we have here, it's just a bit more complex. We have an actual small web page, right? We have a paragraph which says Bitcoin costs. We have another paragraph which is dynamic. It has nothing inside it, but it has an ID called price. And you have a button with an ID. So hopefully nothing surprising for you at this point in the course. So you've probably seen this 1,000 times already. Now, we're going to make a function. Sorry, we're going to come back to this before we go to that. All right. So now we've seen how to get the data, transform it to something that JavaScript understands, and to actually use parameters out of it, right? So before we move forward, I want to show you an easier, more modern way of actually dealing with asynchronous JavaScript. So this is called async await. So this on the left, they're called promises, where you tell your compiler to run a function, and then when it's done to run something else, that's promises. Here, these are asynchronous functions. So what is an asynchronous function? It's a function that you expect that it will have asynchronous code running into it. So let's try to do it a bit easier. We're going to define a new function, get Bitcoin price. And if you want to use this async await procedure, what you first have to do is you have to define that this function is asynchronous. So this is one way up here, but I think this is how you can also do it. Async function, yes. Just by using the word async before a function and its name. You can also do it in this way right here. This is a more modern way, so I suggest I actually just do it like that. Const Bitcoin price equals. So normally you were doing this thick arrow functions, but now you have to put the word async. So what does this mean? JavaScript will take a look at this function, and it will know that inside it, there's places where the code has to wait for some execution to finalize. It means that when you get to something like waiting for a response from the server, or later we're going to learn that, for example, reading files is also an asynchronous operation. While that operation happens, your other functions or your other code can run freely, right? That sort of runs separately in like a place that it does. Okay, let's type it down. Maybe it gets a bit more clear. So we're going to do the same fetch, but in this way. So now, instead of declaring, writing the function and then doing .then, we're going to simply say, I want inside this function to just wait out. Oh, yeah, these are images. Sorry about that. There we go. I'm going to copy this. Okay, we'll do a fetch. And we do, okay, and then we do a wait. So before I move on, I will now do here like a console log response was received. Yeah, and don't worry, like you're not gonna master this from the first time, but come back to this video if you need multiple times to understand this asynchronous nature of JavaScript. For example, like I personally was already developing for 3 years at least, and when I met with asynchronous things in JavaScript, it also took time for me to really get it. So even if you already have experience with software development in general, this might still be a very confusing thing. Because also the way we read text, right? We read from top to down, and we always expect things to happen in the same manner when we look at software. But here we're speaking about events and so on. So to give an idea of how async await works, this is the function which we're going to actually run now, get Bitcoin price. And let's take a look of how this looks like. We're going to refresh. So yeah, I refresh, and immediately after some milliseconds, I say, I see that response was received. I'm not printing out the response. But now, let's say after it, this to be printed in the end, right? So now take a careful look at the asynchronous await. So up till now, you were expecting the following thing, that you run a function, everything from that function runs, and then the next thing will happen afterwards. You probably have that expectation normally, but because this is an asynchronous function, it means that at some point, for example, when it gets to this await part, at some point, your JavaScript compiler is going to pretty much stop here, let this operation happen somewhere there in parallel, and then it is just going to continue further down the line. So if I refresh, let me save, refresh, what do we see? We see that this text was printed before this one, right? So why did this happen? It's because this is what your Chrome engine did. It went here, you declared a function. Declaring a function doesn't execute anything. It went further and was like, okay, I should start executing this function. And that's exactly what it started doing. It went here. It said, okay, I have a variable called response, and it got to the await parameter. So what it did when it got to the await parameter, it said that, okay, we're going to do this operation, but I'm not going to block what comes next. So while your web server is thinking and preparing your message to give you back, this web server, right? While it is waiting, you just continue, you just continue doing your stuff. So that's why this piece of text appears. Then, you can have a lot of other stuff happening here, and it would be fun to see actually after how many of them, you get that message. That would be actually pretty interesting. Let's take a look. Okay, after even a lot of them, because yeah, the printing operation takes pretty much no time. Back to this. Yeah, so what happens is that when it got to this part, your engine just continued, understood that, okay, I should not be blocked by this part, but I just should continue executing stuff. But somewhere in the memory, it knows that when this is done, I all of a sudden should come back to it and then continue doing my stuff inside this function. So that's an asynchronous function, okay? So that's why we first see all these messages, but this message appears later is because this operation took time, right? But we didn't block execution. We didn't block the rest of the code to run further because this is an async await, not, yeah. I guess there's that. Yeah, you'll try more of these things on your own, and yeah, you'll come back to the video. It's something that takes time to master, but yeah, in development, especially as a full stack developer, you can't not learn these things. Yeah. Okay. So back to the code. So in the same manner that we did this fetch, also there's in the same manner we do that JSON parsing. So the transforming the response to an object that we can then use. So const, let's say my data equals await response. So we take the output of this, and again that function .json, and then we do console log my data. So as it's probably not surprising, I refresh and I see all that data just as I saw it last time. Will I get an error if we delete async from the function signature? I don't know what you're asking. I don't understand. Maybe come back to that question later. But also something too important, not every function is an asynchronous function, if that makes sense. So you're free to declare a function as asynchronous every time you want, but not all the functions can be awaited, if that makes sense. There's a limited set of things. So for example, reading from a file is an asynchronous operation. Waiting for some data on a USB, waiting for a user to do something. So you learn them one by one. So one of the one that you learn now is the function fetch, and then this one. Later, you're going to learn how to actually make functions like the fetch one. If we do get Bitcoin price equals this. Yeah, if we do this, it will tell you that await is not allowed because await should only happen inside. What happens if you don't declare it's async, but it still has to wait? So synchronous HTTP requests, it's something that people do not do in web development since probably like at least a decade ago. So this is still an asynchronous function, but we're not waiting for its answer. So if I'm going to print, what do we see? Yeah, response.json is not a function. And why is response.json not a function? Because if I print response, so let's see, how does this response look like if I don't use async await? Let's save. Yeah, and I see something a bit strange. Something called a promise, and yeah, some stuff I don't understand, and yeah, some proto, whatever this is, and then I see the promise result. But the thing is, this is just a way in which the Google Chrome console tries to kind of represent how a promise works. So at this very moment, this response had absolutely no data, because what this answers back is not the actual data, but it's more like a promise that something will happen. So you have to say that I want to wait for that to happen. Otherwise, yeah, what you can then do, you can do stuff like response.then. Yeah, so that's something you can do with a promise. I just put a letter K or whatever. So log K. So if I actually wait for that, yeah, there's still that error, but I still see the response, right, as a text, right? So I can, because again, this is a synchronous code that has to happen when something is executed. So some of the functions, they are not meant to be ran synchronously. That's simply how it is. So coming back to this. So let's say we now make a function that we want this function to just give us the current price of Bitcoin in dollars, and then we want to use that function in multiple places. So we're just going to do return my data.usd. You should already know where I get that from. usd.last, and we want this number to be returned. And now we're going to make another function which will will show that price somewhere. So since this is a small web page, let's try to do this. Let's make a small paragraph. We give it an ID, price placeholder. Now let's just call it price. Then we're going to make another paragraph which explains what is this. The price of Bitcoin is. There we go. So if I refresh, that's all I see. And now I want to make another function, show price. Right now we want that price to be shown somewhere. And yeah, this is something that you will also do in the assignment that comes. So it's important that you kind of learn a bit of what happens here. So we have an asynchronous function that will simply give us the price of Bitcoin. And it will do all the parsing, all this, asking for the data, receiving, and so on. So if I do stuff like get Bitcoin price, there we go. You might be surprised. Sorry. I am surprised. Give me a second. Yes, of course I have to run. I have to actually run the function, right? So I save it now. I refresh, and again, I don't see a number. I see a promise. I see a number here, but again, I see a promise. And why is that? It's because if an asynchronous function does not return its value just like that. It returns a promise that that value will be there at some point. So how do we deal with that? Again, we make this an asynchronous function, right? And then we want to wait for that price. There you go. So what happens now? We say that this function, whatever it does, wait until it's done and only then give me the result back. And if I'm going to print it out, yeah, I have the number, just the number. That's exactly what I needed, nothing else. So, and then, something that you already did a lot of times, we're going to do document.get element by ID, price, inner HTML equals price. So there you go. Now you have a very simple DOM application that shows you the Bitcoin price. Yeah, and every time I refresh it, I think it refreshes only once in 15 minutes. They also have certain limitations, so they don't just continuously stream the data. So so this is pretty much you can call it an end-to-end application, right, from the web server to the user. It's a very simple one, but that actually makes sense. JS is not that stupid. Yes, the Java guy has spoken. Now let's do something a bit more advanced. So yeah, I suggest you only use this as the way to deal with stuff. But when you Google things of like how to do a request or how to parse things and so on, you might see a lot of times the fetch and the then, the dot then. Yeah, so don't be surprised. Like both ways are quite correct. This is how people try to do it most of the times. And one of the reasons is now imagine that you need to chain like 4 type of asynchronous events. Then you have to go like deeper and deeper every time. You have to wait for something, do this, do that, do that. And you get into something called like the callback hell. It means that you have so many functions calling each other that you don't even know what comes from where. Well, this kind of syntax helps you to not deal with the callback hell, because it still to a human looks like, line by line is executed. It's quite clear. I'm waiting for this. I want that. I'm waiting for this. I do that. And then you don't have to go into this very strange construction. And then, yeah, imagine you have four chained things, 4 chained events. Then, yeah, you just have 4 different lines rather than, 4 different layers and whatever this is. Yeah. So yeah, it's same, but it's different. Let's go to present mode and go a bit further. Yeah, so this is the function that I just showed you pretty much. The only additional thing here is that I make the function happen every time I click a price. I click a button. So when you click get price, that function runs, but it's pretty much what I showed you up till now. And again, the code will be available on GitHub as usual. It's already available, I think. Now, a bit of theory about HTTP requests and networking. Yeah, you don't have to go much into details, but as well, you can't just ignore some of this theory. So I'll find maybe some YouTube videos that explain this maybe in a nicer way, but you have to understand a bit of the basics of HTTP. And also, maybe this also shows some terms that I sometimes use and maybe they're not really clear to you. Give me a second, let me check this. Yes. So every URL, every link has multiple parameters. So let's take a look at the image behind here. So first of all, there is a protocol. So HTTP and HTTPS are the protocol that we're going to use in this course most of the times. And the whole web just runs on this mostly. So this is the one that describes the protocol. Next, you have the domain. This is the web page itself. So google.com, linkedin.com, anything like that. And then I have your path, okay? So this path can be, you can have multiple layers of path, and they kind of try to look like a path in your Microsoft Explorer or like in your computer. It's just like a different way of showing different layers of abstractions, I guess. So this is the path part. And then you have something called query parameters, okay? So I'm about to show you an actual link that uses query parameters. But the thing is, yeah, to give you an idea of where you use these query parameters, a query parameter is like, it's a variable that goes with the link, right? Let's say you go on linkedin.com, right? And let's say if I go to my page, this is a bad example, I'm sorry. They actually use it as a path. Let's find something better. So let's say you go on google.com and you search for, Shopify, whatever. We see that this is your web page. I'm going to copy this whole big link right here. So we see quite a lot of information here, right? So, come on. So this is a protocol, right? So we're going to remove it. This is the web page itself, yeah, google.com. This is the path /search, right? And after the question mark, we have query parameters. And query parameters are divided with an and sign. So we see that the first parameter, it's a variable called q, equals, and this variable has a value Shopify. So this usually means Google. For Google, what this means is that, yeah, I was looking for something called Shopify. And here comes all this other kind of information, like source, like, anyways, a lot of the parameters. But if I'm not mistaken, if I'm going to delete all of this, I'm actually going to write slash, was it search? Was it search? Yes, search. And then as a query parameter, I'm going to say Q equals Shopify. Yeah, I still get the same data. So some of these parameters, they're something linked to you being shown the right ads at the right time and so on. So sometimes, for example, if you click a link on Facebook, you'll go to that link with some extra parameters. And those parameters, they can be read by the server and then they can identify you and so on. But anyways, what's important to know, just coming back to the theory, is that certain links, you want them, yeah, they kind of have the same functionality, but they come with some variables, right? And they are separated with an and sign. And if your link has parameters, you have the question mark, right? So you see a parameter value, parameter name, yeah, with the equal sign. So yeah, so come back to the slide when you need this information. The next thing is HTTP status codes. So far you only seen the happy flow. You've seen the code 200, right? So code 200 and 200 and other numbers usually means success. Yeah, 404 is something that you know a lot of times when it tells you that a web server wasn't found. If the server has an error, you'll find code 501, 502, and so on. So you don't have to learn those, but you should definitely know which one is the success code. And yeah, some of the typical ones. You always use Google to learn those. So that's a piece of theory which is important. This and the other thing, which we'll start learning more in depth maybe from next time, you learn that there's multiple type of HTTP requests, multiple methods, as they call them. So in Google Chrome, when you go to a link, by default, you do a GET request, okay? That means, so this is pretty much just a small piece of information that tells you what kind of operation you want to do on that link. Every web server, okay, so for one single endpoint, if the server developer decided so, for the same URL, you can do a get method, or you can do a delete method, and certain things will happen, right? So for example, if you want to get a list of posts on a website, you'll probably do a get that website /post/ something. But then if you want to actually post something, maybe you do an HTTP request with a method put at /post or something. So the idea is that you're going to learn to make this API endpoints yourself. For now, we're going to just use get. So the fetch method, if you're coming back to this, normally it takes another parameter, an object, where you can define a lot of things. And one of the things that you can do is you say method, and then you say get. This is quite unnecessary because by default, I do a get method. But then later you're going to learn post, delete. Yeah, they probably don't make much sense now. But that's just the idea that one URL can have multiple functions depending on how you call it, right? And different things can happen. For now, we're just reading information from the internet. We're not sending anything back. So we're just going to use a get or just a fetch as it is, and that's it. Now, let's actually use something that uses query parameters. Okay, maybe it gets a bit more clear. The same website, blockchain.info, has another, as you can see, same URL, yes, different path. Okay, so you already learned that. That's a path. And then we see some query parameters. But let's actually show it how it looks like in reality. Let's go to this one. So we were at /ticker. Now we're going to go to Let me just copy it. There's quite a lot of data in it. 1 second. Yeah, you'll also have this code in GitHub. So let me copy this code right here. So here as a currency, we're going to write USD. I'm about to print out this in a bigger text. So we're going to make the following request. Yes. Is it readable? Do you see the link? Is it clear? Because we have to go a bit into the details of it. Hopefully you see it.
Yes.
Cool.
Yeah, that's fine.
Yeah. So the protocol, you already seen it. The URL, right? The actual URL, I guess. The path. So we've seen the last time we used this link. Normally, when working with a web server, you'll have this part the same. Yeah. You'll always go to a different path depending on what kind of request you're doing to it. And some requests require you to give some parameters. Okay. So this one was a simple. I just give me, you know, the value of all those. Give me the value of all those currencies. Currencies. But then this function, what this one does, it will tell you how much Bitcoin can you buy with a certain amount of currency. You can find this documentation on their webpage. It's just I'm showing you this because I already like did my pre-research, but then later we're gonna like find documentation on a lot of other APIs. So this this API request expects you to give 2 parameters, right? And the way you send those parameters is by encoding them in this URL. So if we see one of the parameters that it's expected is the word currency, and we give it this value, this means we're looking at a new parameter, and we have value equals, and it expects a number back. Yes. So let's copy it. Let's see what do we actually have at this link. Oh, it tells you value is missing because I forgot an equal sign here, and I edited it in the wrong place. There we go. So. Yeah, probably this is not readable, but here I said that how much Bitcoin can I buy with 500 of this currency? I'm going to now write 5,000. Yeah, obviously one more zero, and yeah, there you go. With $500,000, I can buy nearly 8 Bitcoins. Okay, so what if I don't write one of the parameters? Sometimes you get an error back, right? So this is the way you write those parameters. Now, oh, did that change that fast? Okay, yeah, right. So coming back to the slides. Now, too many things opened. There we go. So back to the slides. Now, let's say we want to make a function that does simply, that we don't have to every time to do this fetch and response and so on. We want a simple function that we can call and tells us how much Bitcoin can we buy with a specific amount of currency. So we made a method just like we did last time, but this time it uses 2 parameters, currency and value, right? 2 arguments. And then what we do a fetch, and we see that instead of just writing a static URL, we're making a string here, right? Again, hopefully no surprise for you of how to make a string. So what we do with this string, this part is pretty much static, right? This is the endpoint where you're making the request. And then, yeah, currency, we type it as it is. We do the equal sign. Here we actually put the first parameter and a sign, which means we're looking at a new query parameter, a parameter called value equals, and now we put the actual value of the value. That makes sense. So after you run this, what this function will return, actually this one doesn't return anything, but in the one that you'll have on GitHub, it will return you that price. So let's just I guess copy paste it right here. Why not? So get Bitcoin price. Let's call this how much Bitcoin can I buy? This will be our currency value. Let's take this from here. 1 second. The other side. So we put now this URL. Yeah, so again, same URL with those two parameters. We again have to, of course, also wait for the data to be parsed or like on read. And then what we return, because we're not given back that whole object, we're just given a number back. We just want to return that number as it is. So I'm going to return my data. So now the show price, what we can do is that we can say, I have to put this new name. And let's say this will be a variable called amount. And then, the currency, let's say again, USD, 1,000, again, 100,000. So this number will go here, which eventually will be part of this URL. And then we want to print that amount. Just going to do a console log, and then we run this function. So for now, we're just going to print it in the console. So let's refresh. Oh no, response is not defined. Give me a second. Response. There we go. Refresh. So we have that number. So with this amount of dollars, you can buy this amount of Bitcoin, and there you go. You put in a bit of design work, and you can actually have now a small application where you can type in a number of dollars, and you can get a number of Bitcoin back. So maybe there's already a lot of applications that do that, but yeah, it's a real life thing that you can do and actually use. Now, later you're going to learn a lot of other APIs. You're going to get familiar with it. Each of them have different kind of documentations. I'll send you a list of links where to start your exploration. I now have a slide about security in HTTP. This might be a bit too in depth, but I'll just simplify it to the following things. All these requests that we're doing so far, as you've seen, were pretty simple. You go to a link and you get information back, right? So that's not really secure because everyone all over the world can pretty much go on that link and get information. So yeah, data is not hosted like this everywhere on the internet. Also, even if, let's say, you give a service like a weather service, right? And you have some API that you give to the people for free, you still don't want someone to abuse it in such a way that he just constantly, tries to download the data from you. Make a function that gets you Bitcoin for free. Okay. So the thing is, there should be some sort of security or some sort of way to identify yourself when you do a request. So you're not going to learn this now or in the next lesson. Hopefully we're going to get a bit into it later. But the most classical way is through a username and password. This is already a way which people don't use anymore, but just to give an idea. Let's say you request information such as your chat messages, right? Or your personal files, or you request something which is only linked to you as a user. So normally what you do, you send a request, let's say, the link of a server / my messages. And then the server tells you, you can't just get your messages. You have to tell us a username and password. And then your web page sends back the same request, but with a username and password. And then you get the data back. So functionally it works, but security-wise, especially nowadays, this is really a no-go anymore because your username and password is constantly going places throughout the whole World Wide Web. So you don't want that to happen. So a more advanced way that happens nowadays is through something called tokens, authentication tokens. You can see these words used interchangeably, bearer token, whatever. So normally how that works is that you send an authentication request to the server with a username and a password. It's all about Alice and Bob. Yeah. So you send like your username and password. You get a token, and a token is just a very large piece of text. And that piece of text doesn't really mean anything. It's just a big code that you use it every time you request something private from the server. And then the server, he looks at that big piece of text, and the server knows what that piece of text means. You know nothing about it. You just know that you have to, it's like a small key, it's a token. It's like when you go into a club and they put a stamp on your hand, or they give you, maybe like an actual coin or something, whatever. And then that's how well, for example, if you go in a hotel and they give you these things on the hands, so then they can scan them. So you don't know anything about what's inside that chip or anything, but they can use it to identify you. And this way, your password and username doesn't have to go all over the place, all over the internet. Yeah, you will implement this a bit later. But for now, just learn it at the theoretical level. So as I told you, also one of the reasons to have this kind of authentication is because you don't want people to abuse your API. You don't want someone to write a piece of code that will send 100,000 requests per second to your server, and your server is supposed to give that information back every time. So obviously they should limit it somehow. And also maybe you should be identifiable in case you're trying to use an API for some nasty stuff, right? For now, we're looking at very basic information, but yeah, I mean, there's other APIs which can give you information about transactions of people. They can give information about location of nuclear power plants, and they want your program to be identifiable in some sort of sense, right? So one of the examples, and this is an API that I suggest you try exploring from next time, is GWT similar to auth, or these are completely different technologies? Similar, yes. Different technologies, absolutely, also yes. There's even more advanced ways where you even get like a two-factor authentication with a phone and so on. I mean, there's people literally doing this all the day, just security and implementing the security rules. So you as a web developer or as a full stack developer, you need to know how to work with them, but not be able to fully implement them from scratch. That's important, because there's a whole field of encryption, decryption, and all this kind of stuff, which it takes a lifetime to learn. Okay, so this is one of those APIs which does not allow you to simply access it whenever you want to. Okay, so the way it works, so this API is called openweather.org. So if we go on openweather.org /API just to see this, this is pretty much a list of things you can request about the weather. You want the 5-day forecast, you want some climatic forecast, hourly forecast in the last 4 days, and so on. You can go into the documentation, and it will tell you what kind of request you should do and what kind of response you should receive back, right? And what kind of parameters you should add inside them. So each API comes with the documentation, and later you're also going to learn how to do this documentation. But first you need to know how to use it. So you notice that every request, it asks you for some API key. Okay, so this API key ensures the following things. So all these APIs, it kind of seems kind of like too good to be true that all these APIs are out there usable for free. Well, the thing is, they're free until a certain limit. So if we speak about this, so some APIs are indeed like open, you can do whatever the hell you want to them. But the ones which give you really valuable, expensive information, they have some pricing. And what most of them, they do the following things. They tell you as a developer, you can do 1 million calls every month. You can make a whole application with 1 million calls a month, and you'll never have to pay anything. You don't even have to give a credit card or anything. What you have to do is that you have to identify yourself once, ask for a key, and with that key, you can do as many requests as you want until you reach 1 million, right? So, and then after that, if you try to do a request with that key, it will tell you that, you reached your quota, and yeah, we're not going to answer you anything back. Also, usually what they do is that yeah, they give you certain information for free, but a lot of other things, they will come only if you get the paid version, right? Okay, so if you want to make a weather app for the next time, you'll have some other options. I suggest that you go on this website, you register yourself. It's absolutely free. You just log in, email, password, that's it. And then you go to the My API keys. Yes. I don't remember my pass. Yeah, cool, nice. So you go to API keys, and here you'll see a list of keys, and I see one. You have one by default, and then you copy this, and then you can use it to actually make requests. So back to the slides, we see the following thing that, yeah, so based on the documentation, I've seen that if I go to this URL and I use one of the parameters as q equal a name of a city, and then there's always a mandatory other thing, other parameter called app ID. Here I'm supposed to put my key. And my key, this is what I copied from that website. This is what identifies me as my account. And I can do this 1,000,000 times per month, and after that, I'm not allowed to do it anymore. Every API comes with its own limitations, own data, own anything. So this one, every time I will do how is the weather in, and I'll put this parameter, I'll get all this object back. Yeah, and what this object has, you obviously can read that in the documentation, but I find the name, again, that I asked for. I see a time zone. I see clouds, if there are no clouds. I see the coordinates of the place. I see the speed of the wind. This object I didn't open. In fact, I can, I have the code here on the side, so I might just as well copy paste it. Give me 1 second. I'm just going to copy. Yeah, so hopefully this should just run if my token didn't expire. Yes, there we go. So I'm doing, again, this call with these two parameters, just like in the documentation, parsing the response, and then, yeah, just printing it out. And I see the following. This is the object that I get back. Obviously, a lot of information here. If I look at the weather, I see, yeah, some array. I see some. Anyways, each of them means something differently. This is the direction and the speed of the wind. Yeah, when the sun will rise and set. Oh, in the main, we also have the humidity, the pressure, and the temperature. So quite a lot of information that now you can take this object, right, and parse it and do something with it. And yeah, since we're at it, let's make this print the temperature in Sydney is currently, and I want to take the stress, this object, right? I want to do dot main, because that's the structure of the object, right? Like I see it in dot main, dot temp. I save, I refresh, and I see the temperature in Chisinau is currently, yeah, okay, this is in retarded units from, I don't know, I think Fahrenheit or something, but probably there's a way to request it also in Celsius, right? So yeah, there you go. And now I can make this print with nice images. I can also conditionally save that, yeah, coming back to actually printing the whole response. Now let's just get to the slides. I have that there. Now in your web page, you can do stuff like, okay, if I have information that, let's say, the clouds are 0, then I show a nice sun, right? If I get other information about the clouds, maybe I want to show a nice image of the clouds. Or maybe I want to make an arrow that shows based on the direction of the speed, right? Maybe I want to have an arrow that shows that. And maybe yeah, so you can use this information now to display it in a nice, beautiful way and to actually make an application. You can now even make an application which takes in a text box, it can take the name of a city, and then that name is added as a parameter to this request, send there, you receive back the data, and it will display you how is the weather there. And you can pretty much just say, okay, now show me Chisinau, now show me Bucharest, now show me that. Hopefully that triggers a bit of your imagination. Now, I have here a list of links that I suggest you to explore for next time, and also to explore them for the next assignment that's upcoming. These are, this is a list of APIs which are free of use, no need to use credit cards. You can request a video. Yes, the YouTube API is impressive. With YouTube API, you can even, you can really do a lot of stuff there. I don't know what to tell you. Like, just Google it. But I suggest, I don't know what to tell you. You can try the documentation. It might be quite a complex API to start working with, but also it might be good because usually if something that comes from Google, it's usually very developer friendly. So yeah, YouTube data API, yeah, they even give you code samples. What? I don't see JavaScript here. There you go, use cases and code samples. As you can see, there's quite a lot of details here. You also need an API key. Obviously, you'll have to ask for that one. It uses quite advanced kind of authentication, but if you want to go in details, of course, you can go. You can probably get a lot of information, such as reading the amount of views, getting a thumbnail of the video, actually downloading the video, getting only the audio, getting the video, and just everything you can imagine. You can have an API that automatically posts comments. You can have an API that posts videos in general. And same if you go if you use the Facebook API, you can literally automate everything you want there. This video, there you go. I've seen people doing this. This video inside the title, it tells you how many views it has, right? And it's right, because he uses a YouTube API to update the name every time a new viewer comes in there. So pretty impressive stuff what you can do with APIs. Web scraping is also something fun. Like, for example, you can use Instagram to pretty much scrape 10 pictures from each of your friends. Or maybe that's something that, something nasty from marketing perspective, that, for example, you automatically send messages to all your friends and spam them with a specific information, it's a specific product information, and then you tell them, okay, hello dear, insert name here, and then read about this product. So really a lot of things that you can do with these APIs. Back to the slides. So some of them, which I think are pretty cool, but again, actually this first one is nice. This first link, if you go on this one, GitHub public APIs, this link is a list of APIs which are free of use from all the domains. It's just a small list. It's definitely small based on what's out there in the world. There's an API for cat facts, and make sure they either have no authentication or API key. Any other more advanced authentication, we'll learn a bit later. So random picture of cats. It's a funny one. I mean, it tells you how to, you'll explore it on your own. Anime, anti-malware, art and design, books. I put one of those, for example, you can get information about books based on name. You can write the name of a book and you'll get the author back. Something with business. You can automate Gmail. That's very nice, and that's what I use every time when I deal with emails in general. So even like managing the emailing list for this course, I mean, I didn't start type for each of you like, oh, hello, this is the course and so on. I pretty much had an Excel sheet with the names of people who were accepted and which were not. and I simply ran a script which said, okay, for all the people that are accepted, send them this email or not. So yeah, calendar APIs, cloud storage, cryptocurrency, right? Some of those that give information about cryptocurrency. A lot of those nowadays, everyone wants their own service to do something with crypto. Currency exchange, just a lot of stuff. So try them. Check the ones which either don't have authentication or simply have an API key. For most of them, you need to register yourself somewhere or somehow. So yeah, good luck with the exploration. And the last thing I suggest you, especially when you do the exploration, to use something called Postman. You had a file of how to install Postman, but honestly, it's really just as going to postman.com and download it. You probably have it for every operating system nowadays. So Postman is something for you to test API requests. And before you start writing code to connect to a certain API endpoint or so on, it's always advisable to use something like this. I'm going to clean it up. So normally this is how the interface looks like. So what you do, this is how the main page looks like. You just do plus here. And by default, you're doing a request, a GET request. So these are the methods that we're talking about that we're going to learn later. Here you have to write down the URL. So let's again use this URL. And as you can see, I'm copying the URL with parameters. I'm not sure how readable it is. Maybe later in the video, when you watch the video, it'll be clear. But what you can see here, that the parameters are separated because they were detected here. And when I do send, I get my data back, right? And I get all the information about it. So every time you're going to try a new API, I suggest, you open Postman and start just, typing that URL, trying to change some parameters, see if what you get back. Do you get an error? Do you get something else? This is, for example, that ticker method. Yeah, see, I immediately get the data back in a more structured, nice manner. So yeah, probably it's not very readable now, but later you'll take a look. Yeah, so yeah, try explore at least 2 APIs till next time. And now the assignment. So in the last 6 minutes, it's really up to your imagination, right? But the minimum requirements are the following. It should be an application that uses real-life data to display information. This can be, a plot showing corona cases. This can be a weather application. This can be something that you type in a name of a song and it gives you back the lyrics. I think I have the one here. There you go, lyrics of docs and so on. So for example, you type in the name of a song and it tells you if that song exists. And if it exists, it will print you out the lyrics nicely, why not? Or that cocktail app. You can use multiple APIs. That would be even cooler. Imagine like combining some of those things, right? Maybe, I'm thinking of something now. Maybe use 2 different COVID APIs, one that tells you about how many people are vaccinated, one that lyrics plus YouTube video. Perfect. Exactly. That's a good one. So imagine you write the name of a song, and if it finds it, it will give you a link of it on YouTube or Spotify or why not. And then below you'll have the lyrics. Yeah, that's a quite nice one. So yeah, using multiple is advisable. If you just use one, that's good enough for you to learn and to understand what this is happening. And you should have at least one dynamic parameter in the API request. So as I showed you how we did like the price of Bitcoin, like giving a number, for example, like, so the user should give something, right? So either the name of a city, and then you give the weather back, the name of a song, a number of dollars to convert to Bitcoin or Ethereum or so on. So at least one parameter. These are the minimum requirements. These are some ideas right here. But yeah, I suggest you come up with something crazy because also this is something that will give you a good idea of what you want to do as a final project for this course. And I think this is a time when you actually start making something interesting, you kind of understand why you need you get a good feeling of what you really can do by knowing a programming language. Okay. So yeah, now we have 4 minutes for questions. Let's start. You can also unmute and talk. How did you find the lecture? Is it interesting? Is it frightening?
It was pretty charged.
Nice, nice.
I had a question I want to ask earlier.
Mm-hmm.
So if you call a function that is asynchronous, we have to make the function that it's calling also asynchronous.
Yes, so it depends. So if you don't care about the result coming from an asynchronous function, right here. So if I want to just run get data and do nothing with that data, I simply do not use await, and I just don't have a variable to read it, and I don't give a, like, I don't care, right? So yeah, that's about using the word await. So if I simply want this function to run like I do here, see, I don't have any await behind it, because I just say, just run this function, and I don't care about what it returns back or when it returns or whatever it does. That's it. So, but then if I want to use this function get data and actually get its result back, that's when you use await. So you'll have to do this in practice and you'll kind of get an understanding. So you probably, for a lot of times, you might forget to use the word await, and you'll see that you get this promise back, and it'll be confusing. But yeah, just come back to this every time you need to. So I think this is a very good example of how to chain to asynchronous functions. So could you please explain what do you mean by saying use multiple APIs? Does that mean we have to do fetch 2 different sources? Yes. So yeah, fetching from 2 different sources. Let's say which one we're talking. Yeah, I'm just going to write some pseudocode. Let's come back to this. So let's say I want to get let's say I want to get the information about how much I can get with this sum and how much I can get with double the sum. Let's say you make this one function which will combine those. Okay, let's do it. Let's actually write some pseudocode. So let's say this will be some link which will give you the lyrics of a song. Get my lyrics.com or something / maybe there's something like this. And then here you would put the song name. And then you wait for that answer. You fetch it, you parse it, and then you do another request. Obviously, this has to be named somehow differently in a better way. Get my video, and maybe here they expect something like that, name, whatever. And then you put the same song name, and then you have these 2 variables, and then with those 2 variables, you want to do something. Let's say. Also, they can be in 2 different functions, right? So there can be a function called get lyrics, and it will only return. And this is one way. And then